All right, well, thanks for sitting in on this presentation we like to present today. So we only have 20 minutes, so we're going to be doing this at a very high level. Let's just get started with this. So it's just a general outline of our discussion today. We're going to give you, Scott's going to give you a background on the project and why we did it. This is actually, there were a number of phases in this, but the original project was to do one thing and then we extended it to do the digital twin. We're going to talk about the system process. We're going to talk about the optimization criteria we used for the optimization part of the project, kind of go over the results that we got from this project, and then spend a little bit of time talking about the digital twin and what we were trying to do and how it was implemented by the FlexSim team. So before I get started in the modeling stuff, I'm going to turn this over to Scott, who's going to just talk about kind of the background of what we were trying to do.
Sure. Just to kind of go back in time, this facility was owned by AGC at that point. This would have been about 2019. Just to give you a background on what this facility does and what we manufacture. This location produces sheets of glass utilizing 2 float lines. We actually melt the raw materials, the sand, to produce sheets of glass. From smaller cut sizes up to what we call jumbos, which are 130 inch by 204 inch glass, and thicknesses from 5/32 up to a 1/2 inch thick. These are combined at the end of the production line to build what we call sling packs. These sling packs are transported and stored in a warehouse in what are called L-bucks, which is a steel rack, until they're needed for shipments. The main purpose of this project was to redesign the warehouse and the shipping areas to streamline the handling of the glass from the production lines to the warehouse, and then from the warehouse to the docks or the trucks to get them shipped. The goal was to minimize the material handling, which we call touches, and that reduces waste, which is breakage inside the facility. We were also trying to eliminate weekend loading of trucks. We wanted to get to 45 trucks a day in 5 days, down from 7 days. So what the project was designed to do, we were putting this model together to justify adding the 10 above grade shipping docks for the specialized loads. These docks were strategically located in line with the warehouse areas to minimize the handling of the glass packs between the float lines and the shipping. So we also added 3 crane bays and 6 class 5 overhead cranes. So the model itself was used to back up our assumptions on the model itself, on what we were wanting to get put in place for a $9 million project. So I was brought on at that time. Bill was brought into the project to develop this model to prove out the assumptions that I'm gonna say the stakeholders had on redesigning this warehouse. So we added a 56,000 square feet addition to our existing warehouse, and then created a new layout to reflect what you will see in the model. At the bottom of the screen, you can see it right now, but I will turn it over to Bill at this point to kind of step through what we did in the model itself.
Okay, so it's a pretty straightforward process. As Scott mentioned, they're manufacturing glass. So glass is being manufactured at different float lines. It's being assigned to a tugger to deliver it to a storage location as a sling. Each one of these dashes or little symbols, yellow symbols, represent areas we were trying to do optimization. So the first step is sliding the glass to a bay and location. So we would run the optimization logic, and it would tell us, okay, here's where you should slot this material in storage. Then we'd actually use a tugger and then a crane to store the glass in a location. Once it was stored, then there were also trucks coming with orders that were then assigned to a bay where they were going to load up with the glass. So there was an assignment of the truck / order to a shipping location. There was an assignment of that stored glass to a truck order. So we're like, okay, well, what glass do you want to pick based on a number of factors? We actually pick the glass with a crane, or we use a forklift to get it on the truck. And then finally, at the end of each day, after all of the trucks were loaded, we had a maintenance activity where we said, okay, we want to maintain this warehouse and consolidate loads and things. So how do we want to maintain it so that we're the most efficient? And there were some general criteria that we used for each one of these for slotting, picking, and maintenance. So like for slotting, we knew that the warehouse utilization, how full it was, had a big impact on efficiency. We wanted to look at the bay utilizations across, there were multiple bays. So we wanted to know how does that affect efficiency, whether we had empty or filled storage locations, should we be spreading part types across bays? For picking, for example, one of the big problems they have right now is unburying slings because you have to take slings that are above it on the rack and move them out of the way to get to the sling you want. So we wanted to be able to consider that in our factors for picking. You have to move if the sling that you want is not in the same bay as the truck you're loading, you have to take it by forklift over to a different bay. So there was some time associated with that and target level. So we kind of brainstormed up front what we thought might be important. And that information then was put into these tables. So these are the weighting factors that were used for the slotting and the picking. So you know, when the model runs, first thing it does is it says, what are all the potential locations that I could store something, for example? And then what it would do is say, okay, well, how good is that storage location for me to store this particular sling in? And so we were looking at things like, well, we want to store the same parts in the same location. We wanted to put high volume A items in A locations that were closer to the dock. And so essentially the way this worked is it trained, you know, we said, okay, well, we run this, how much of a penalty or a reward do you get by storing something in a certain location? And so when we ran the optimizer, these were all our variables that we were looking at. We allowed it to vary the penalty or the reward so that we could see how much that factor played into the overall efficiency. We did the same thing for the picking, for example. And so at the end of the day, this is the magic here, is what are these weightings and what things are the most important as far as getting the most efficient warehouse and loading the trucks the quickest. So I'm just going to show real quick the model and how it runs. And I don't think it is sharing my screen, so I'm going to move this one over.
You had it.
Yeah, we did see it.
Oh, you
was
did
there.
see it.
Yeah.
Oh, well, look at that. All right, can you see it?
Yep.
All right. So this is the actual model running. And you can see there's different bays with cranes. So there's a high bay, and there's these 3 bays here, which were new. And each bay has these 3 bays have 2 cranes in them. And one crane is basically storing glass into locations. And one crane is taking the glass that's stored and it's loading it onto a truck. And you can see that this is color coded. We basically have virtual locations which are color coded by how full that location is. So a green location means there isn't a lot of material in it. Gray means there's nothing in it. Red means that it's full or nearly full. And so what the model will do is whenever glass is made, it determines where in this all these storage locations it wants to store it. You'll bring a tugger over, it will park it in a bay, and then a crane will then store it in one of those areas within that bay. So this was how the model worked. And we were tracking things like how many orders were being shipped per day, per week, when we were completed shipping the orders for the day. Okay, so we ran the optimizer. We ran a number of experiments.
You're still showing the model, Bill.
Am I?
Yeah, there you go.
There's a little bit of a delay. See my slide?
Yeah.
Okay. So we ran the optimizer. And again, for our optimizer, all those parameters that I showed earlier, those were the things that we were looking at changing. We gave them each a min and a max. And then we were trying to optimize the time that we were completing shipping across all the docks each day. So we wanted to make sure that we were completing it obviously before the end of the day because we didn't want to have overlap into the next day. and we were hopefully going to try to reduce the amount of shipping. As Scott was mentioning earlier, before we did this model and this new concept, we were shipping 7 days a week, and we wanted to get down to a 5-day per week shipping schedule. So that was very important. This just kind of shows some of the graphs that we developed just to verify that the solutions that we came up with were feasible. This just shows the last shipment that went out each day. 24 hours, which is right here at the peak, is the latest, obviously, you want to go. And you can see there was a general by week. You could see the Mondays usually were pretty busy, and then they would go down the middle of the week, and then we'd have the weekend. So this is just kind of telling us what time of the day we were completing our shipping. This one was just showing crane utilization. There's 9 different cranes. You want to see which cranes were the busiest based on how we allocated their work. Same thing with the tuggers and the forklifts, just trying to get an idea of utilization. We just wanted to confirm that we had the right amount of equipment on site. The conclusions on this project were that we could definitely see that the 24 rules of thumb that we used to manage a warehouse did have a significant positive or negative impact on the efficiency. And one of our recommendations after doing the space project was to consider how to integrate the rules into planning activities. We also identified that if we overfilled the warehouse, in other words, we have too many things in the warehouse, it takes away our ability to have some flexibility, and it greatly reduces the overall efficiency. You have to do a lot of unbearing of materials, and you're very limited on where you can store things. And so one of the things that we came up with is you needed to determine when you needed to take things out of the warehouse and store them in a different area where they maybe wouldn't move as frequently. It was also important to maintain the warehouse bays on a regular basis. So if you didn't make sure to consolidate the storage locations on a daily basis, things started to get out of whack, and your efficiency would also go down. But it did look like one of the big takeaways from the project was just to verify that the concept would work, which is, I think, what we found. But the model was able to help us identify things like how many of these short bucks we needed for unbearing. Short buck was a location that was a temporary location that were in strategic locations. So if you needed to unbury a sling, you didn't have to travel very far. You had a place you could stick it. It helped us identify the number of racks that would be required, how much space we need in this other warehouse, and it also verified that we only needed 3 docks in one of the bays. I'm gonna let Scott now go back to, so he's going to kind of talk about the digital twin part of the project.
Sure. As Bill and I were finishing up our presentation with the stakeholders, one of the first things out of the site manager's mouth was, I love the fact that the model tells you where to put each sling in the warehouse. He says, I want you to figure out a way to use FlexSim so my guys on the floor can access that, and it tells them where to put the sling. Because what they were doing was they would just try to find an empty space, and it may not have been the most optimum space in the warehouse. So with that in mind, if you read this, what's in front of you, it says the real-time optimization of the warehouse goods storage and dock assignment to improve picking efficiencies using the algorithms that were developed in the FlexSim model simulation. We also wanted to be able to pull live data from the AGC database into the model. When we created the model initially, we took the data, put it into Excel sheets, and then imported the Excel spreadsheets into the model. We wanted to be able to tap directly into the database to eliminate that step so we could do it on a more frequent and user-friendly basis. So we wanted to be able to optimize the parameters, auto-generate the scripts, and export and install those scripts into a live warehouse management system. The scripts were to include slot assignment, which is the optimum sling placement in the zones, and dock assignment, the optimum trailer assignment to the docks. We wanted to put the trailer in the right bay that had the majority of the material that it needed for that shipment. And that's to maximize the picking efficiency. Go on to the next slide, please. There we go. So as we were going through this, we wanted to be able to import on demand the current inventory and the shipping requirements from the SQL server. We wanted to be able to run the model and the optimizer on demand whenever we wanted to, offline. We wanted to be able to export the optimized rules of thumb to the SQL server. The operator would use a digital twin via a handheld scanner to place slings of glass coming out of the production lines to the optimum crane bay and the optimum location within that bay. We also wanted to do the shipping trailer dock assignment based on the optimum bay, based on the product availability in that bay. So optimum rack location recommendation being the scanner to the operator. And then also at the end of the day, once all the shipping requirements were filled, to use the daily rack maintenance recommendations that were generated from the model. So that's a lot of information I just rattled off to you. I know it is, but it does everything that the model was designed to do, and then export it to where it is in a user-friendly position for a handheld scanner to be able to read into those algorithms.
Yeah, and the hope was that, FlexSim is not necessarily a good real-time tool, but it's great for evaluating rules of thumb. And so the overall hope was that you could take the model, you could run it, let's say every couple months based on what products you were producing, and you could fine tune your rules of thumb, and then that information then would go directly into the warehouse management system. So you're always fine tuning it and learning and adjusting. So if it needed to be adjusted. So I think it was trying to strike a chord between using FlexSim as a great tool for coming up with the rules, but then also using it hopefully as seamlessly as possible to drive the actual warehouse management system. So for this project, we engaged the FlexSim group to help us with the digital twin portion of this project. So we had Zach and Anthony that were involved and met with us and went through how the simulation currently worked. And the way this kind of shows the diagram on how the simulation was working at the beginning of this digital twin phase. So we had our simulated warehouse, which you just saw. There were resources like tuggers, things moving, visualization. And the simulation had a database of locations, of inventory, of what orders to run, what production was coming out of the glass areas. And so these were feeding this FlexScript-based heuristic search algorithm. So it was very much, there was some heuristics that had been built into the model that whenever glass was made, it would go to that heuristic and it would say, okay, what kind of glass is this? Where do I want to put it? It would score all the different locations and it would come up with the best location. And we used OpQuest as part of that to try to optimize the best locations, the best strategy. So this worked great for us to do the verify of the concept and come up with some insights. So what we wanted to do then is say, how do we link this to the warehouse management system? So this is really what was the end of that phase of the project. What Anthony and Zach did is they took the FlexSim code in FlexScript and they turned it into SQL queries. And so the SQL queries would be more conducive to be able to use outside of FlexSim within a SQL server. So what they did is they went through all the code, and there was quite a bit of code in this model. They converted it all into these queries. It still worked with the model. The model still works just like it did before, but now it can generate these queries. And then those queries there was a converter they created because the SQL server that's used by Cardinal Glass is slightly different than the SQL code that's used in FlexSim. So they created a customized T-SQL converter, which then converted those queries into T-SQL queries, which then are stored within the real factory warehouse management system. And then that works with the SQL Server database. And the idea being that now an operator at the float glass area, when they package the glass, they can scan it and it will run the exact same query that we would have ran in FlexSim. It will look at the inventory as current state inventory. It will look at the rules that were set up and the weightings, and it would give them a recommendation on where they should store things. Now, it doesn't mean they necessarily would store it there, but it would give them a recommendation of where they should be storing things. So it was pretty slick in how they did it. Now, if you ask us where we're at right now, Scott, let Scott talk to that.
Well, as we were getting to the end of the phase where we were getting the last set of crane rails put in, and we were stepping through this with Anthony and our IT group, writing the code for the scanners and everything like that, that is when Cardinal Glass bought this facility. So we're not in a steady state yet to where we can put that out on the floor, because the business model has changed fairly radically. And I can't get into that specifically, but it's different than the way AGC would have done things. So we're kind of waiting for the dust to settle a little bit, and then we will go back in and adjust this accordingly. But it was fascinating. I mean, right as we were getting to the point of wanting to roll this out, everything kind of came to a screeching halt. So the warehouse has been built, the cranes have been put in place. This has been, I'd say, taken to about a 95% completion level. We're just waiting to do the final bit when we're able to get to a steady state on what the production and shipping is going to look like.
So I think that's all I have to say. Scott, do you have anything you want to add?
No, that's pretty much all I got.
What questions do people have? Do you have any questions?
Yeah, thank you, gentlemen. We do. One question's come in so far. How long did it take to develop the initial model and then the digital twin model?
It took us, what, about 7 months to do the model off and on?
Yeah, it's hard because it was a lot of off and on, because as in a lot of projects, it was getting the data. So we spent a lot of time working on getting the data. To build the model itself probably was just a couple months to build the model.
But with a $9 million project, there was a lot of questions we had to get a lot of specific answers for the model itself.
And we worked very closely with the staff and the people in the facility to make sure that what we were doing accurately represented how they would currently run the warehouse.
As far as the digital twin aspect of it, I would say we were working on about 6 months, 7 months, but it wasn't 7 months of total dedication, nothing but that. Everybody had other things they needed to be doing as well. So we were getting to that point. We were starting from scratch with FlexSim, and we were trying to determine how we wanted to do it as well. So there was a lot of brainstorming that went back and forth between us and them to get to the point to where we're at.
Yeah, and as a user, I've been using FlexSim for over 20 years. I think that this is a good example of where you take a model that's used to do a project and you say, how can I use this as a part of an ongoing improvement effort? And I do think this kind of shows, at least showed me that, and how you write the model originally can have a big factor, could be a big factor in the usability going forward. So it is very possible to take a project model and convert it into something that can be used ongoing. What other questions?
Yes, was the result from the optimization fed back as input into the model during the model run?
No, we ran it through the optimizer. So it would run a bunch of experiments with different, essentially we ran historical period of time. So we ran that historical period of time for several iterations using the optimizer just to come up with the best. We did not get to the point where it was adjusting as it went. At least for this phase, those weightings were only meant to be good for that period of time, which is why we said you'd have to go in probably every quarter or something and probably make adjustments.
Excellent. Let's see, there's another question. This is probably more for a FlexSim developer, but someone is asking if there's any plans by FlexSim developers for connecting the simulation model to IoT-based platforms. That may be one they could possibly answer. I do know there's a lot of them, and it may be difficult to support absolutely everything out there, and so that can be tricky. Let's see, another question. What was the reason for the T-SQL procedures? since FlexSim can directly pull data from a SQL server?
So the SQL Server used those queries. They were queries. So it was basically just integrating queries that were developed directly from FlexSim that would be compatible with the SQL Server that Cardinal Glass currently has. So it was written specifically so that it would be compatible with the current warehouse management system.
You mentioned that currently, or when you finish the initial model, in reality, glass would be stored at the first empty location. So what were the criteria for selecting in which bay to store?
That was basically based on the shipping history. So we wanted to put the high movers, the ones that turn, the product that turned the most closest to the docks, because that would reduce the travel time to go get it. So it was looking in, there was a lot of factors involved. We didn't want to have all the one product in one bay. We wanted to be able to spread it out a little bit. So, I mean, there was a lot of different variables involved with that. But one of the main ones was trying to keep it as close to the dock as possible if it's a high mover.
Right. So all the products were they're ABC codes. And so we know what products are A's, and we assigned A locations. And so the weighting, for example, if you try to put an A product in an A location, it would be happy with that. It was a positive score for it. If you were trying to put a B or C in an A location, it was a negative. But
one of the things, we had about 1,750 different SKUs and about 650 locations. So you couldn't just dedicate one location to one product type necessarily.
Right.
Excellent. Thank you. And how, just one more. What does WH maintenance mean? Is it a type of housekeeping or arranging glasses during non-working hours?
It's trying to empty out racks, because we got to remember that we run 365 days a year, 24 hours a day. The lines never shut down for 20 years. So you've always got production coming off the lines, and you got to have a place to put it. So the daily maintenance was trying to clear out rack locations by saying, okay, I've only got 2 or 3 slings left here. I'm going to move it from this location to this location to free up that whole one, because we were maintaining FIFO. Once you had product in a location, we would try to empty that out completely before we started putting something else into it, to keep from having to unbury things.
Right. And there were some temporary locations I mentioned, those short bucks. They were also using as a place when you were just picking an order and you needed a quick place to put a sling, rather than trying to find the optimal place. We had those locations. So during the shipping period, they could stick them in those short bucks. And then at the end of the day, they could say, okay, now that I'm done, where do I want to put those materials? And so you're always trying to clear out those spaces by the end of the day so they could be used the next day when you were shipping.
Yeah, for instance, one of our crane bays was about 1,700 feet long. So you could pull something out from the far east side and bring it up closer to the shipping dock and put it in one of those little short L bucks just to hold it there until it was ready to be loaded on the truck.
Excellent. Well, thank you very much, gentlemen.
Thank you.
Thank you.
Excellent. That was an extremely informative presentation and a really neat